if you join the Etherpad, it's a lot easier to click on the link for the invite to the Slack. But, yeah, welcome. Good to go?
Let's get going.
All right, cool. Welcome everyone to the 2025 10th anniversary edition of the Scientific SIG. So happy to see everyone. We're going to basically have a chance to get everyone to tell us what your pain point with OpenStack is. Oh wait, no, that's not that meeting. How do you use OpenStack for scientific computing? Stig, just for everyone's awareness, super user award winner. Where's the trophy?
I'm not the
John, where's the trophy?
Yes.
It's on his stand.
All right, fine. I'll let it go for now. But well deserved. We're happy to see you. It's basically something we run at every summit, right? We want the chance for the scientific community to come together and tell us, I use OpenStack for, I have that problem. I would love to know how you guys do that. The thing is that a lot of this conversation happen in Slack, but this is a chance for us to basically get together, Stig to prepare a pub meeting. I mean, just in case you're wondering why you're here to go to the pub at 9, and have a chance for us to basically communicate and meet one another. So, thank you for coming.
Yeah, we should introduce ourselves.
Oh, yeah. Sorry, I feel like everybody knows me. If you don't know me, I'm Michel. Raise your hand if you don't know me. Really? Oh man. All right, fine. Okay, so hi, I'm Michel. I'm one of the co-chair for the Scientific SIG. We've been doing this for nearly 10 years. I'm not gonna tell you much about what but I work for a company called Bethwaite. I'm the Chief Technologies, the VP of AI and Data Science. None of which is relevant for this conversation, but Stig?
Yep, hi everyone. My name is Stig Telfer, and I work for a company called Stack HPC. We're based in the UK. And missing is Blair, who is, Blair Bethwaite is based in New Zealand and works for RIANS, the Natural Research Network in New Zealand. But he couldn't be here today, unfortunately.
So I recommend people look at the URL for the Etherpad. That's the usual way we run those meetings. Join the Etherpad, put your name, whatever contact information you're okay sharing with us, ask questions. That's the way OpenStack usually does that anyhow. And if you're not on our Slack, please join our Slack. This is where you're going to find about 200 plus people that try to follow the research use case. And in particular, if you have questions, that's where you're likely going to find the most chance for people to answer.
So I was thinking to get things going, maybe with seeding a bit of discussion. I was just thinking of things that we have done using OpenStack in scientific computing that I knew since last time we had one of these events last year. So I can begin, I guess. So we fixed a bunch of weird problems that we were having with SRIV networking onto bonded ports, and as a result of that, we get some really lovely latencies and bandwidth in virtualized compute clusters using RDMA. This has made a big difference for us. I've been really excited about how to do it. I was hoping to demo it at some point, but I haven't quite got my stuff together. 4.
I
know, but anyway.
You have a session tomorrow at 4 then.
Perfect, we'll do it then. John, do you want to talk about the NVMe over TCP?
With fast.
Yeah.
Good point. So, we've been testing. Oh, hello. Yeah, I'm John Garbutt at Stack HPC. Yeah, I guess we've been testing this with. Sorry, name the customer, right? Because they're on the keyboard.
Yeah.
Right. So this is with 6G AI They're testing a lot of the VAST drivers. So VAST are developing a Cinder driver which uses the NVMe over TCP stuff. But the driver's still in review. So we've been testing that out, and that seems to be working quite well. Equally, we've been testing a lot of the Manila driver out. So I guess the interesting thing with a lot of the filers is that they are somewhat cloud service provider enabled, in that you can have multiple VLANs trunked into the filer. So we've been looking at doing the tenant VLANs straight into the filer. It's still a little bit awkward to configure that. I'm going to patch them. Well, we've got patches up for Collar Ansible to automate this. They need a bit of a refresh. But essentially, we're looking at creating a share type per tenant, which is a bit awkward but possible. So essentially, inside the VAST side, you've got the what they call a VIP pool, but there's a virtual IP pool that they have to give out to their C nodes. It works kind of similarly. I've done similar setups on the Pure side of things, I guess, but not automated through Manila in quite the same way. And you can expose those shared file systems into the tenant networks. I don't have performance numbers on it yet. Still a work in progress, but that's progressing, I guess. So interesting on fellow travelers and that.
You said it was on VLAN. Is it only like VLAN? Does the tenant networks have to be VLAN for this to be patched through, or can you do it with overlay networking?
That's a good question. I don't know. The reason I'm using VLAN is because I'm using networking generic switch and physical ironic machines, so that was chosen for me. So I was checking the VLAN interface. Yeah, I don't know. I guess that varies on vendor. I've only ever done it with VLAN with Pure and VAST, I guess. Good question, Danny.
It would be problematic to try and tie the XLAN into it with the architecture of Neutron.
I would have thought so. You'd have to get you'd have to talk to Oven, right?
You'd have to do an EVPN gateway, basically.
Oh yeah, you could EVPN it, I guess.
Yeah.
That's true.
And at that point, it's set up for tenant.
Yeah. Yeah, fair point. Yeah, probably not.
I think something that I found quite positive from that experience is that VAST is engaging and committing effort and resources to making new drivers, which is nice, because we don't get a lot of attention from
No,
high-end
that's true.
storage vendors, and it's not always easy to link them up into these environments, because there tend to be different divisions within the companies and so on. So it's something we have been advocating for in other places.
Yeah. Actually, that's true. It's probably worth saying that they've got the keyword to find the docs that you want to read is cloud service provider, which was pointed out to me. So I didn't find them by accident. So yeah, they have documented this for cloud service providers and integrated with that, which is nice. Not the precise words I said, but the non-OpenStack version is quite well documented, which I found after setting.
I guess more widely, anything else interesting going on in storage in the group?
In the room in general.
Well, I don't know how interesting this is, but because storage space cost and we still have a lot of self-cluster with spinning disk, we have been thinking about, okay, for scientific use cases, how about, we have been quite strict beliefs in 3 copies of data, but how about we do like erasure coding for block storage also? How does it work nowadays? And unless you do like rewrite, it works really well. Like the performance numbers are quite, especially for streaming data, we are going to probably move a majority of the storage to EC block storage.
I can say something about that.
Yeah.
So, I mean, it's actually quite interesting. You're sitting beside me, and I guess you missed my talk, but that's okay.
Oh, I didn't miss your talk.
You didn't? You
I didn't miss your talk.
You did. But that's okay, because it was only 6 minutes long.
Oh.
And it was in a weird room. But very interesting. So I'm Dan. I'm from a company called Clay. So I'm on the Ceph Foundation and formerly like building all the Ceph storage at CERN. In the upcoming Ceph release, Ceph Tentacle, which we just kind of tagged maybe today, we have fast erasure coding optimization. So we have previously, you can't read, you can't do substrate reads.
Yeah.
You can't do partial reads, you can't do partial updates. So this particularly kills block storage. Like I found this too when I just left sort of fresh off the boat back in Canada, looked at some OpenStack user, I was like, performance problems, whoa, that's really bad performance. Let's take a look. They're using 8+3 erasure coding, software, getting just megabytes per second on a multi-petabyte cluster. And that's when we kind of like the whole project relearned that this was it was a thing that a to-do. Okay, so do people know what I'm saying? I've explained it weird in a weird story way. Like the bottom line is that in the release that's coming out in like now-ish, we have our Ceph conference next week. You will be able to, on any erasure coding pool, set a flag called fast EC, and it will now, it's a one-way flag, you can't undo it, so give it some time to bake and make sure that nobody else gets their data corrupted, let someone else have that happen to them. But you'll be able to enable it, and you'll get like 5 to 10x performance improvement on your EC. And this is going to be a game changer for block storage. Yeah.
So I've seen more people use it with file, but that might be related to.
You'll be able to,
The same difference,
for
I
file
guess.
it'll be the same.
Yeah.
I mean, the only one that's less relevant, so it's also relevant for S3 because occasionally people are doing range reads, like sub-object reads, but you can't do update with S3, so that part's not. But so what's implemented is partial read, meaning the before, like the current state is if you want to just read out 4 kilobytes from the block device, which is by far the most common read out of a block storage. Actually, if you have a ratio coded block, it'll read, if you have 8+3, like the example I said, it's going to go to the first of the 8 disks. It'll read a 32 kilobyte strike from that one, and then that one will ask 7 other disks to also read 32 kilobytes. So you got to wait for those to see. And then that'll be all brought back to the primary, and he'll go, oh, I only need that 4K. I didn't even need to ask the other ones, and he'll set it back. So that's the read, so that's fixed, but then also, if you've only written for, it'll just only update the correct parts, and yeah, it's just all of the obvious things have now been optimized. So that's like, that was the focus the last of this release because it changes the cost dynamics of block storage completely.
Right. There's some good Ceph Day or Cephlacon talks, aren't there, online?
Absolutely,
I've seen some
yeah.
videos from, I think, some
Ceph Day
ex-GPFS people.
Yeah,
That's right, yeah, IBM threw a dream team. Is anyone from IBM in here? Like, IBM threw the dream team on it, like this was a priority for them as soon as, it was like, actually, in open source this happens all the time. When we first saw this, we already found a fix for it. It had been submitted by some developer 5 years ago in a PR, hey, we noticed this, and that PR just stagnated and got closed. So it could have been fixed before, but then actually they took that as a trigger and it became the whole like initiative for that team. Yeah, and so there's good work from those guys, Bill Scales and Alex from IBM. They're in London, I guess. Robin, they're somewhere in the UK.
Yeah, they were Brits.
Yeah, but great. Yeah, and so you can find the videos.
And that's in latest Tentacle. Is it, or-
It's stable in Tentacle. Yeah. And I was so like originally it was thought we would have to be a whole new pool layout, and so it would only be for new data. But actually, they found a way to just have a switch you could turn it on, and it's like dash turbo.
You mentioned specifically that this is for block storage, but I presume object storage will benefit from that as well?
Well, normally in object storage, there is no way with S3 to write just to modify an object. So for that, it's not relevant, but you do, like depending on your use case, it is common to just say like, get this object, but range like from.
We have a lot of range reads.
There you go. So it'll fix your things. Yeah. It's good.
Maybe
So-
a general, question that may be stupid, but it shows I've never been in this room before. But we for sure talked about virtual swim clusters at our facility, and so far it's been always GPFS for the primary file system. So do other sites really use Ceph for this? So yes.
Yeah, we have a mix of Ceph, NFS, and Lustre.
for various use cases.
Okay.
And the Ceph is really lovely because we also have a grid component, some grid, and so that allows us to also do dev testing, the CVMFS stuff in Ceph, which works really nice.
So, for people who are willing, if you can also type some of the
Oh,
links
sorry.
and things like that in the, for people to be able to look it up, that would be appreciated. Verbal, great, persistence, I mean, we all like persistent storage, right? So,
Dan, I'm curious. So we've worked with a couple of projects converting from replicated to erasure-coded storage. Is there like a well-documented process for that, particularly for CFFS, but also
For
the other
Ceph,
pieces?
for CFFS, it's actually easier, but actually we had designed a fancy, nice way to do it. So the easy way is you just create another pool, and in CFFS you can attach a Rados pool to any directory, and you just move the data.
So
like move MV,
you
copy.
change the properties on a directory or a file, and it will actually move the data in the background.
No, that's the nice thing that we want to be able to do,
But
but we can't do that yet.
you could in principle do opportunistically, right? Every time a file gets written in that directory, then from now on it's erasure coded, but it's still like
Oh yeah, that probably works. Yeah. You have to.
but then you're never sure when you actually finish the migration. So it's
Yeah, a directory has a property which is what pool is it stored, or the files in that directory stored. So
Yeah.
I guess you could change it. It sounds scary. But normally people lay this out. They say this is the all flash directory, this is the slow directory, and then they just
Yeah.
do whatever. You could move, but it's right. Yeah, we had this idea to in place reshape the.
And at the end of basically copying everything up into the new pool, is there an easy way to know that it's safe to take the old pool out of the separate stuff? Or does it just stay there as like a sort of vestigial tail of the what it used to be?
Yeah, that's one of those questions where it's like, people have done this maybe once or twice in their whole life, so you have to like look and think about it. Good question. Yeah, just, let's just look at it. You have to answer that question. You often have to look at the source code and think about it.
Right.
Yeah.
But it's just out of curiosity, isn't that true that it still needs like the root to be like replicated? So in the end, if you have a single replicated pool, you don't want to take it out of the cluster. Because
Right.
like you still want it like a replicated root for like all the not extent but all the like zero size object that's
Okay.
So maybe you can reduce it like.
It's got one object in it, which is the root directory. We can do that.
But you're thinking of stuff that's at the. I think it would be fine. Oh well, you can also just look if there's anything in the directory. Like you could just Rados list the pool and
Yeah.
see
Yeah.
if there's anything there.
Yeah.
That's what
Right.
But I think you can't remove the pool while it's still, while the file system is still running on it.
That's a good point.
Do you have a roadmap for enabling those optimization by default?
Oh, good question. No, I don't, I would have to check. I'm not sure what the plan is on that. Here's the thing. It's like, as with everything, I mean, in Ceph, this is especially the thing. This is like, we call it stable, which is actually quite ambitious. Normally we make things like experimental for a while, but because there's serious business interest involved in this feature, as you can imagine, it's like this one's just stable from the beginning. And yeah, I would still be a little bit cautious.
Couple of releases.
Subscribe to Ceph users and just hope for the best. For other people. No, but in Ceph we don't, just for sure don't upgrade to, we will announce version 20.2.0 and we'll say it's stable. And under no circumstance should anybody upgrade to that version. You should wait till .1 or .2 or .3 until you know several people that already did it. Or you've got a good vendor that tells you it's okay to go ahead.
Well, that's also tied to a lot of dependencies, right? So a lot of people will run will run add-ons. So, you know, as long as the add-ons are not supported, they're stuck.
Right. Yeah, and I'm not that up to date right now on the OpenStack. Sometimes the interfaces, the dependencies are specific OpenStack dependencies as well, but I'm not that up to date on that for technical.
Okay.
I don't think we've rewritten another game.
Yeah, there were a couple of
There was definitely
weird
a
things.
major one there.
Yeah.
Oh, that's useful. I guess to add the question on using Ceph file systems within virtual slope clusters, something that we tend to put a lot of effort into is trying to maximize metadata server performance. And there's a whole slew of sort of non-default optimizations you can apply there to try and lift that. So that's, I think, where the effort goes in managing it.
It was Stack
Talk to Dan
HPC
about
that did it for us, and we get similar performance from the Ceph as the Lustre,
Wow.
which
Super.
they did some magic and it works. That's lovely.
Okay, customer feedback.
I need to stop doing it, sorry.
I would have a completely other topic also on, it touches AI, I'm sorry. But I guess a lot of us, a lot of GPUs and stuff and expensive resources, do people have experience with Blazor? Like, I would very much want to use something like that.
Do. So I've
PS here as well.
I was gonna say, you might ask the
Two
guy
behind you.
yeah. So we've added a new feature in Blazor for flavor reservation,
Okay.
which I like. So what it allows you to do is instead of, it's a bit like instance reservation, but you use flavors instead of arbitrary stuff. So that can allow you to have your GPU as a thing that you do the reservation on. The other piece that we've done is in the, so we've got our open source Azimuth portal. So when you do an instance reservation, essentially your requested flavor UID gets mapped to a reservation specific flavor, and that can cause just a lot of UID sloshing about, frankly. So we have, so in Azimuth we have actually tried to wrap Blazor to make that easier, so that you request the particular flavor, it will, we've got like a little Kubernetes operator that goes away and puts the Blazor reservation, sees the UID that gets picked, and then can do the mapping. So it's not, it's still not the easiest to use thing. I mean, I pushed Pierre quite hard to see if we could get away without doing that. We didn't find a way, which annoys me, but this was a way forward.
So I see the annual review is gonna go great.
So we've got, so Blazor does do that, and what I would say is Blazor, when you use Blazor within your cloud, the other thing to mention is it's a host by host, hypervisor by hypervisor choice. So you don't have to have the whole of your cloud using Blazor. It could just be for GPU nodes.
Yeah.
He says, knowing that that's a good option.
Yes.
So the that's one side of it. The other side of it is, by default, Blazor doesn't really have. I mean, there isn't really a quota or limit system, right? There's a few of them.
There's no quota integration. So by default, a user could create a very big reservation taking all the resources on the cloud. And so what we did a few years ago with another site deploying that has been using Blazor for 10 years is to implement some custom policies to define what should be the maximum usage of the reservations. And it's very flexible. It's based on webhooks that are calling a server, and then the server can implement all the intelligence you can have. So and you can also make built-in limits just on duration or size of the reservations. But if you want to make something a lot more complex, like for example with John we built this system that's based on credits. So you can give an amount of credits to users projects, different projects, and then each time they take a reservation that subtracts from the credits, and then when they don't have credits anymore, they can't reserve.
It's called, we called it coral credits because of the coral reef cloud thing that was Stig's idea. The coral credits is essentially trying to apply like Slurm resource hour limits into Blazar essentially. So what it tries to do is it uses the placement resources as the key from the flavor to decide what the cost is, if you see what I mean.
Yeah.
So you kind of like with a certain number of PCBUs, certain numbers of RAM, MB, and the important thing when using this with well, so the flavor reservation system, it does respect the extra specs of your requested flavor as best as it can, but it's not currently trait aware or magic. So what I recommend when you're doing GPUs is to actually add an extra resource, a custom resource class to model your GPU. So say you've got like A100s, H200s. If you model that as an extra resource class, that is the same. That limits the VMs that can land on the machine with the GPUs. So Blazar picks the right hosts, and it will also give you the key to put your credits for GPU hours basically, because you would have custom underscore, name of your GPU as the credit system.
Okay.
Sorry, that was a long ramble, but
No. It's good to have some context in like when we start to look at this, because we need to start to look at something like this.
It's something that at CERN we are looking at, and this year we are going to start building a prototype around Blazar, because we have this similar use case of reservations, not only for GPUs, that is the main thing with these scarce resources, but also scenarios of someone asking for some physical hardware for a workshop for a few weeks, and then giving it back. So we want to see if this fits into that, because otherwise it's a challenge to manage all the life cycle of this list of people of hardware.
Yeah, so we're using it quite a bit with the UK SRC community. So what they're actually using the Blazar for is that they basically put all of their hypervisor resources in the Blazar control. And the reason they like it is because it tells them when the cloud is full quite canonically. They really just wanted not to have no valid hosts, that favourite error message of mine. And they wanted it to say that the cloud is full. And Blazar is actually quite good at doing that. The one thing I would say is if you go down that road, be very careful with the NUMA pinning packing of your VMs, because if you don't get that right, Blazar can say yes and the cloud can be full, which is awkward. Anyway, sorry.
Is the calendar in Horizon now, the reservation calendar?
So it has been for many years for host reservation, but we don't really have an equivalent yet for instance reservation. Which we should,
Nor flavor reservation.
Or flavor,
But there is general Blazar integration in Horizon.
Yeah, there is. There is a plugin, and you can create and manage your reservations with it, just like when you launch an instance.
Okay.
But there is also some visualization, but it doesn't cover all the use cases.
Yes, as we're talking about resources, how to optimize the usage. Just a question, because this is something we started in the past with opportunistic spot instances with this APRA project, and at some point we stopped using that. We are at the point of thinking of reviving it or not in the coming years, and I wonder if is anyone using that or doing such a thing like opportunistic spot instances on the cloud to optimize resources.
We did try and add that inside Blazar.
We did something similar with Preemptible, but it was not. It was done because of the problem you had integrating it into Nova. We did it completely outside, but it requires having Blazar in place.
The main thing I'd say about integrating that into Nova now is that the blocker that we had before was essentially there was no precedent for moving an instance between compute cells. We didn't actually have the code paths for that. So when you don't find a host, you go into the cell 0 database, and basically in order to get preempted out of that, if you had a pending state, we'd have to move you out of that database into the other one. there has since, Matt Riemann did a load of stuff with the cross-cell resize and the unshell between the cells, and so that is now is much more solved problem.
Okay.
So I definitely would say it's worth a refresh.
Bring it up at the PTG.
Yeah,
Yeah,
because
sort
of
of.
weeks. I mean, it won't happen tomorrow, but it's something that we start to consider again. We know that some people were using that, and so
It would be good to see.
So we also have a short meeting, but before, I'm not going to interrupt anyone, right? That's not the plan. The plan is just to mention that for whoever is here, to take a picture of that screen. I'll move away. Don't take a picture of me. You don't need it. Trust me. You'll get the link to the Slack. I encourage everyone who's not on the Slack to please join us. As you can see, we always have interesting questions happening. Join us there, right? Stig, what do you want to move with now?
Aren't we out of time now? 5:30?
It's 5:35 supposedly, so we can run a tiny bit longer, but let's try to be respectful of everyone's time.
Not necessarily for discussion, but I'm going to the pub, so do hit me up. I'm English. Is anyone working towards carbon sustainability, capturing actually energy costs, emissions across either OpenStack or Islam HPC specifically? I've got details of what we're working on in that, but if anyone's got any institution or researchers working with them that are needing it for their grants, I'd love to hear how you're going about it. Because it's
Did you see the BBC folks article on it? They did quite a good write-up of what they were doing.
It was a few years ago, but
Yeah.
unfortunately,
I'm counting on you to post that
scaffolding-
article in the Slack.
Hmm?
I'm counting on you to post that article in the Slack later.
thank you.
I think they published it at the time of the summit in Berlin,
Yeah.
22, so it would be 3 years ago, and it was based on something called Scaffold. Unfortunately, that was developed by a French company which is not maintaining it anymore. But I think there are lots and lots of options in this field. It would be good to,
We've tried a few of them out.
yeah.
We can try
this guy.
Let's try and
this
get
one,
one
yeah.
post out.
Seems I don't know if you have a contact to the BBC people, but I can go through Jonathan Rosser to understand if they're still using that. Maybe
Yeah,
they did something else.
I don't. It'd be really good if you could talk to Jonathan
Okay.
about that. That'd be nice. Yeah, Doug has done a write-up of a couple of the stuff we've tested. We need to get that out there.
Okay.
Yeah.
Wasn't
This
very
is one of
positive.
the seams from
Yeah.
Mahendra Paipuri.
We had to patch it to make it work with Color Ansible, I think.
I've always done a lot for CPU, GPU most of the time, a little bit in the RAM space, but nothing that incorporates.
Oh, the host and the cooling things. So the BBC article had quite a nice, we're totally over time, right? But there was a nice model of carving up what your DC usage is in various ways. And I think there is some kind of standard now for like attributing it to certain particular servers and then carving that up. It's all very wibbly maths, as far as I'm concerned, but I can't think of a better way, so maybe that's good. It's more like, we've got so much cooling in these racks, therefore these racks are taking that amount of the stuff. These are the DLC racks, this is this much. It's kind of just like a proportional down to the server thing. And then on the server, it's kind of using CPU usage as a surrogate for the percentage that you give to the different people. And the other one is like, there's a final bit which is the unused host taking up some amount of carbon, right? So yeah, there is a bit of a framework around that, I think. We should try and find the articles on that.
Yeah, we've got 2 publications on the different approaches. We've gone through all of them.
Okay, nice.
And then we got feedback on it with other people going, you didn't try these other 5 ways. I'm like, oh.
Well,
Okay.
Actually, in 2022, I was discussing with someone from a company, a Czech company, which right now it's eluding me, and like actually they were like more interested in actually the active power saving rather than the like computation. But I don't know if I streamed upstream anything because it was that, like
there is a new feature on this upstream.
They were actually bucking nodes, like stacking VMs and switching off hypervisor that were idle.
Yes.
And then like actually having cycling them up when like the scheduler was saying like.
So it's worth looking. So Nova Nova now has a power down the PCPUs that aren't being used feature.
Oh, okay, that's nice. So
which is fairly stable these days. But it does require the PCPU rather than vCPU so that it knows it's free, right?
Okay, yeah.
Related to that, I think Myrontis was working on a schedule that would actively move your VMs.
Yeah.
Yeah, to like pack more or spread more.
What is that project called? It's not Watch, is it?
No, I think they were building it inside Nova. I think I saw that announced a few months ago. I'm not sure it was released yet.
Yeah, I didn't know about that.
I mean, like live migrate to somewhere else.
Yeah.
Yeah, I mean, there wasn't a project that used to do that, like based on power and try and consolidate essentially.
We
How would it deal with different architectures?
It doesn't do that.
Okay, so you need to know what it is.
I try to make sure everybody gets to the bus at some point.
Yes, we should. Yes,
Yeah.
like the fossil stuff.
We can consume some carbon dioxide in classes of beer later.
And don't forget to congratulate Stig HPC.
Great. Hopefully, see lots of you later at Bomasi, and yeah, we can carry on a nice discussion.
Yeah.